Let's start. Today we will talk about one of the most common graph traversal algorithm called DFS. DFS means depth first search. Its another brother is DFS means its another brother is BFS means breadth first search. DFS means depth first search. DFS brother is BFS means breadth first search. Breadth first search. Now we'll talk about solely about DFS, depth first search. Let's see an example. Let's say we have talked about edge list structure in previous video. Now let's see an edge. This is the edges. Okay, yeah. 1, 2, 2, 6, 2, 7, 2, 0, 0, 3, 4, 5. Okay. Now let's see how the graph looks like. 1 to 2, 1 to 2, 2 to 6, 2 to 7, 2 to 0, 0 to 3, 4 to 5. So we can see this is a disconnected graph. Now how depth first search will work. We can see if we start from source 0, we can reach 1, 2, 3, 6 and 7, but we cannot reach 4 and 5. So we have to take 4 as a source for another session. Okay, let's start with 0. From 0, depth first. So from 0 we can go first. So we go 2. So from 0 we go to 2. From 2, let's say it's in a stack. I think it is much easier to understand. From 0 we go to 2. Okay. Now what is the neighbor of 2? 1, 7, 6. So let's first go to 1. 2's neighbor is 1. Okay. Now what is the neighbor of? So we have visited 0. We have visited 2. So what is the neighbor of 2? 1. Push 1 in stack and 1 is also visited. Okay. Now what is the another neighbor? Let's go, it is 7. Okay, 7 is visited. Okay. Oh, sorry. From 0 to 2, 2 to 1. Now 1 has no neighbor. no neighbor. Okay, yeah, 2 is a neighbor, but 2 is already visited, so we don't count it. Okay, just unvisited ones. No unvisited neighbor. 1 is already visited. Pop 1 from the stack. This is just stack. Okay, done. 1 is done. What is the who is the stack's top 2? What is the neighbor of 2? 1 already visited. Okay, let's see visited. Then it's be easy. We know 0, 2, 1. Okay, so 2's neighbor is 1 but already visited. 7 no visited, so add 7. 7 has no neighbor, that is unvisited, so pop 7 and we also add this in visited. Okay, done. Another neighbor of 2 is 6. Add 6 in the stack. 6 also visited list. Now any neighbor of 6 that is not visited, no, so pop 6. So 2's neighbor is 1, 7, 6, all are visited. 0 also visited. So now what can we do? We pop 2 from stack. Done. Now who is in the top of stack? 0. Who is the neighbor of 0? Adjacent neighbor of 0. Okay, we are talking about adjacent neighbor. So who is adjacent neighbor of 0? 0, 1, 2, 6, but they are already visited. 3 is not visited, so add 3 to the stack, add 3 to the visited list. Okay, now 3 is visited. So any neighbor? No, 3 has no neighbor, that is unvisited. Only 0 remains. Any neighbor that is not visited? No. So let's pop 0 and the stack is empty. So